name's Diane. You're currently watching the Just Kidding Row Show. Thank you so much for joining us. Each week, we like to introduce our home audience to different crafts and hobbies that can be enjoyed by the entire family. And this week, we are fortunate to have a very gifted magician on our show. His name's Jeff Evans. And in fact, in my opinion, Jeff is probably, I know he's the best magician in the county, but I would say
Not
even
the only one.
Oh, now. So, but before we get started, Jeff, can we look in the cameras and say hi to Mr. Feeney?
Hi, Mr. Feeney.
Hi, Mr. Feeney. Do you remember Jeff?
I'm an old Lakes Elementary student also, so.
Yeah,
He's
so,
teaching.
yeah, great teacher.
But this is not just a magic show. This is my science magic show. So these on the table are science experiments that viewers at home can actually recreate right in their own home. But first, I have a little optical illusion that'll work right where you're seated. So everyone do this. In fact, do it right through the video camera. Hold your fingers out in front of you so your fingers are almost touching, and raise your fingers until they're right in front of your eyes. Perfect. Now, don't try and look at your fingers. Just keep looking at me. And as you look at me, a miniature third finger will appear floating in between your other fingers.
I'm looking.
Isn't that weird? I do that at home. I see that little finger floating. It freaks me out.
Wow, that
All
was
right, so
pretty
that was
amazing.
one magic trick. Now some science. And here's the challenge. I call it the water and oil challenge.
Okay.
This is water with green food coloring. I always add green food coloring just to make it look like science. And this is oil, cooking oil. And the challenge is, how can we transfer all of the oil from this cup into this cup and all the water from this container into that container without using any other containers?
And are there holes in these containers? I don't see
I
any.
don't see anything coming out.
Would it matter what shape the containers were?
Actually, when you do it at home, just use round, regular glasses.
Round. Okay.
Use plastic, and also put a pan underneath it so that you're not going to spill anything.
Okay.
So this is based on liquid density. So if I had a big container with oil and water, what would happen?
You mean them together?
Yeah.
Then they would separate.
And what would go to the top?
The oil.
Bingo, because oil is less dense than water. So in this case, I'm going to carefully, I'm putting a postcard on the container first. And because it's laminated, it's going to not absorb the water. So this works because the air pressure is pressing up, and the air pressure is actually greater than the water pressure pressing down, which is kind of weird, but true.
Wow. So you promise if a kid did this,
Well,
even with a paper cup,
totally.
it's going to, okay.
Yeah, kids,
I don't want
you
their
can,
parents yelling at
No,
them.
you can totally do this at home,
All right.
but don't do it when your mom and dad are there. No, of course you do it when you're there. That's when you want it, because they're going to freak out too. Now, slowly pull the postcard away so that the liquids can coalesce and come together.
Oh, is that not cool?
I do that at home, and I just laugh and laugh when that happens.
Wow.
So after the liquids have all come together, slide the postcard back, and then once again, through the magic of air pressure, there's going to be a little bit of liquid that spills, but that's why you
Look at that. So
do it over
anybody can do that.
pan.
I can hardly wait to get home and try that myself.
And voila, science magic.
Doesn't matter how much oil you use or what shape
Actually,
the
it
containers
does.
are. Oh, it does?
Fill the containers all the way to the top. That is important. And that's why you're going to spill a little bit. But
And
it's
equal
nothing big.
amounts? Does it have to be equal amounts?
Equal amounts, yep.
Okay.
Okay, now it's time for the balloon blowing up challenge to see who has the most hot air. So the challenge is simple. I've placed a balloon inside of a bottle, and the challenge is who can inflate their balloon the most.
Is this a trick?
Kind of. It's science magic. So
Is there a special way to
anytime
blow
you want,
on this?
well, just the way you normally blow up a balloon, see what
Okay.
happens.
You gonna say go? I can't get mine to blow up at all.
That's impossible. Neither can I.
Oh, okay.
Yeah. So why not? Why is it impossible to inflate the balloon?
Well, for me, it would probably be impossible even if it weren't in the bottle, but you're going to tell me it has something to do with the bottle.
Well, it has everything to do with the bottle because there's air
Air in the
trapped
bottle.
in the bottle
Okay.
that can't escape. Unless we do a little bit of science magic. So, Diane, I want you to go
you're gonna
wiggle, wiggle, wiggle over the top of my balloon. Good.
What did you do?
I got it. Now, go wiggle, wiggle, wiggle over the top of my hand again.
Oh.
Check it out. Can you actually see inside of the balloon? There's nothing covering it.
No, there's nothing covering it.
So why isn't the air coming out?
I don't know, Mr.
Wait,
Wizard,
wait.
tell me.
Go wiggle, wiggle, wiggle again. That's some
Okay.
science magic. Now, here's the way it works. It's a trick. I actually poked a tiny hole in the back of my bottle. Now, it's too small for you to see on camera.
Did you just do that when we weren't looking?
No, I did
Oh, you
this
had
at
your
home.
finger over it.
Yes, secret preparation. So when you do it, poke a little hole. The first time you're pretending to inflate it, just put your thumb over the hole.
Okay.
And then the air in your lungs isn't strong enough to compress the air in the bottle.
Okay.
That's what's happening. So nothing happens until you move your thumb, and then the air inflates the balloon. Put
then
your thumb
finger
over the
it.
hole, and the air can't get back inside of the bottle, so it stays inflated.
So when I go wiggle, wiggle, you just take your finger off.
Bingo.
Oh, you're smart.
Science magic.
You're smart. These are things our kids could do at home.
Yeah, even grown-ups can do these. In fact, this next one is fun to do in restaurants.
Okay.
So imagine that you're in a fancy restaurant and you've ordered your food, and there's always that time in between you order and the food comes, and normally people just spend that talking and building relationships with the people at their table. But what if you could play with your food or do something to cause a commotion in the restaurant? So that's where I come in. And do you know what this is?
It's a purse?
It's a magician's coin purse, and so I'm going to use that coin.
Oh.
Use the biggest coin you have. That's a $50, which is perfect, but quarters work too.
It's a real coin. 1971. There's nothing about it that's fake.
2 forks, and since you're going to be using the forks later to eat, don't use your forks. Go and borrow them from another table. Yeah, you're probably going to want to kind of zoom in on this, because what I'm doing is I'm placing the tines of the fork kind of sandwiching them around the coin, and now I'm just going to move the handles of the fork either in or out so that the center of mass is balanced right over the point where it comes in contact with the glass. Voila.
Oh, wow.
Now, if you look really close, you can actually see that it's wobbling a little bit, and that's because it's kind of precariously balanced, for one thing, but look at how low the handles of the forks are.
Can the cameras get that coin in
Oh,
there, I
yeah,
wonder?
they totally see it.
They got the forks, but do they wow.
So, and the reason that this is able to balance is that a lot of the mass is in the handles of the forks, and so it has a low center of mass, and so it's stabler than it looks.
So if I touch that, it would tip.
It would fall over, but I like to do
I wish
this.
they could see the coin. There's the coin. There, they got it.
So anyway,
Wow.
waiters and waitresses, they love this.
Oh, I bet.
And then when you're done, you just take the forks out, and you can put those back on the other person's table. Hey, since we've got the cup, here's a fun thing with inertia. You're going to need a postcard, toilet paper tube, and something that's heavy like an 8-ball. And line the 8-ball up so it's directly over the cup. And don't use a glass, use a plastic cup. Don't ask me how I learned that.
Is that plastic?
That's actually plastic,
Oh,
yeah.
that's glass.
Yeah.
Okay.
So what I'm going to do is I'm going to real quickly...
So it wouldn't work
Flip-
with glass, or you just
Oh,
don't
it
want to
works.
break it?
It just breaks it, yeah. It only
Okay.
works one time with glass. Here's the way inertia works. Something that, if an object has weight and it's in motion, it wants to stay in motion. But if an object is at rest, the way the 8-ball is now, it wants to stay at rest. So I'm going to real quickly remove the postcard and the tube, and just for a split second, the ball is going to stay suspended in midair, not moving, because the inertia wants to keep it in one place. But then gravity is going to take over, accelerating it towards the cup at 32 feet per second squared. And when it does, hopefully, it lands inside the glass.
Oh, boy.
Bingo. Hey, here's one more thing that's kind of related to inertia. It's centripetal force. I can actually turn the cup over without dropping the ball. that centripetal force. Now, you can also do this with water. You can fill it with water and do the same thing. So try that at home. I'm just kidding around.
I think
Actually,
they'd have
you can
a
do it with
mess.
water, but do it with a plastic cup and do it outdoors. if you check
Yeah,
that.
okay. It's a water.
Okay, now it's time for some math-a-magic. So there's a pair of scissors for you. And this is something called a Mobius strip, made out of newspaper, and I'm going to explain it after we do it. So go ahead and pick up the pair of scissors, and it's just a piece of newspaper that's been taped together. Cut a little slit in the middle of the newspaper, and then use the scissors and start cutting all the way around the loop. So viewers at home, think to yourself, what do you expect to see?
You're not double cutting, you're just...
I'm just
Okay.
going all the way
Does it
around.
have to be straight?
It doesn't have to be totally straight. And this concept was invented by a German named August Ferdinand Mobius. So it's called a Mobius loop or a Mobius strip.
So I'm not going to have two separate strips, huh?
No, we're going to find out. I'm just going to leave mine there for a second.
I'm catching up with you. Do you want me to connect them? Oh, I'm there.
Yep, cut all
Can
the
I
way
do
through.
that? Can I
Yep.
cut right there?
Absolutely.
And connect it?
And then go and show the camera your two loops.
Oh.
So the Mobius strip ends up being one giant loop. Mine, which was a little bit different, check it out.
Is two. See, that's what I thought I
Linked
was going to
together.
get.
Yeah. Well, there's different ways of taping the pieces together.
Ah, it has to do with how it's taped.
Yeah. You can do it with any type of
I thought
paper.
mine would look like
I'm using
that.
the Olympian. If you take a loop and tape it together like this without any twists, and you cut around, you'll end up with two separate loops, which is what most people would expect you would get.
Yeah.
But if you give it half a twist, that's called a Mobius
Ah.
strip. When you cut around, you'll end up with what you had, which is
Oh.
the one giant loop.
Okay.
Now, here's an even more interesting thing. On a Mobius strip, if you take your finger and put it at one point and trace around the newspaper, even though I'm starting on the outside, it goes to the inside, it goes all the way around on the inside, and then it curls back around to the outside. So it ends up tracing on the inside and outside. And it's used in belts for cars so that it wears evenly on the inside and outside.
Oh.
So there's actually a practical application for it too.
How interesting.
Here's what's even weirder. These two, the way you make this is by giving the piece of newspaper a complete revolution. So if that's half, one more makes a complete revolution. Tape it together, and
then
you'll
you
get the links.
two.
But guess
The
what?
links.
If you get rid of one of these, what you're left with is another. Wait a minute. It seems to have. That should be a Mobius strip. I believe that if you cut that, you would end up with one giant one.
Oh, okay.
And you can keep doing that and just seeing what happens. It's really weird.
Did you like math and science when you were really young?
I love science.
See, that's because of Mr. Feeney, probably.
But now, we're going to have a boat race. We're going to make a boat.
By the way, you can't
that
do
out.
that with any paper. I heard you say you could do that with any newspaper, but you can't. You can't do it with the PI. I'm sorry.
Very funny. Yeah, did you hear that the PI folded?
Yes, that's why I
But
said
it always did, it in the middle.
that. Oh.
All right,
You
so that's our boat. And go and
Okay.
hold it up so the camera can see. You can use any type of paper for this.
Looks
any
like this was
newspaper.
made out of a card, so it's a
Yeah.
little bit stiff.
The important thing is that there's a channel cut in the center, and notice the aerodynamic shape of the boat.
Okay. Aerodynamic.
Go ahead and set it in the,
Yeah.
in the container.
Aerodynamic.
So this science magic is based on surface tension. If you take water and you place it on a piece of glass or a piece of metal, it'll kind of have a domed shape. It's not totally flat. And that's because water is attracted to water, so it wants to stick together. But in this case, detergents and soaps destroy surface tension. So I want you to take the Q-tip, dip it in I'm using Dawn or Joy dishwashing liquid. Okay, that's enough. And now I want the camera to really come in on this because it only works one time.
On
and
the
what's going to
Q-tip?
happen? No, I want it to come in right on the boat.
On the boat.
Because right now the
Jim knows
waters are
about
still,
boats.
nothing's happening. But when you touch the middle of your Q-tip right inside of the boat, something
In the
weird's
middle,
going to
right
happen.
there?
Yep.
It's going to. Oh, how fun is
Yeah.
that? Why does it make it move forward?
Well, it destroys the
doesn't it
surface
sink?
tension,
Yeah, but I
and then
thought
the
it would make
water
it
goes.
sink.
That was you couldn't see it, but the water. Now it's not going to work again, and you know why?
Why? Because it's already been broken?
Yeah, that soap extends
Oh,
around the
that
surface and
is
then also penetrates down
cool.
into the water too.
Doesn't matter if I take it out and move it?
I'm going to sell that boat. So that's a fun one.
Wow. I hope they got that. Did they get that on camera? Do you know?
Oh, they got that.
Did they get that?
Let's see. Earlier, when we did the experiment with the forks and the coins, I should kind of explain what this is. This is based on the same idea in that the balance point, the center of mass, which is there, it's easily able to balance because there's a lot of mass that's lower than the balance point. Imagine the Space Needle. The Space Needle is huge. It has a lot of weight up towards the top, which would seem to make it kind of tipsy. But if you could see underneath the ground, that's where actually most of the foundation, there's a lot of footings that go deep, deep. And so that's the same idea here. You've got a lot of mass that's low down, so it keeps it steady. All right, here it is, our grand finale. It's Chili Rescue. Oh, and we should probably say where people can learn more about these cool science experiments.
Okay, where can they learn more? In the library?
Exactly, at the library. And the Dewey Decimal System for the science experiment books
Is 793.8.
That's the magic section.
Yep.
793.8. And then the science experiments
Oh, wow.
are in 507.8.
Okay.
But you can always look it up at the library. But anyway, here's the challenge. The situation is that an ice cube, right here, there's an
I'm
ice cube
impressed you
inside
know
of the water.
Dewey numbers.
Oh, the
Usually
library and I are good friends.
I'm good. Did you learn a lot of these tricks from the library?
I
or
did,
library books?
yeah. I
All
check out
right.
these books, and that's how they learn the magic and the science.
Oh.
So the challenge is how can we rescue the ice cube from the water using nothing more than a piece of string and some salt.
Okay, so you're saying I'm going to take, right now I'm looking, there's a glass of water and there's about 4 ice cubes in there.
Yeah, we
or
need to
something?
rescue the ice cubes
And we're going to take those ice cubes, all 4 of them out,
using the piece of string.
and just using this. Well, and salt.
Yeah.
Well, I guess I would grab an ice cube and tie a knot around it and lift it up. But I know
Good
that's
luck.
not what you're going to do. Okay.
Well, we're going to take advantage of a little bit of science magic. We're just going to get the ends of the string wet and set it on the ice cube. Now, what happens when you put salt on ice?
It melts it.
Yeah, it melts it. Because salt lowers the freezing temperature of ice.
Oh, I didn't know that.
Just takes a few seconds, but it's not going to melt through all the ice because there's a big chunk of ice there. So what's going to happen is it's going to melt it, but then with all the ice that's still there, it's going to refreeze the liquid that thaws. And when it refreezes,
It's gonna be
something
one chunk of
weird
ice?
is going to happen. Well,
It's
slowly
going to freeze
pick
the,
up that end of the
it's
string.
going to freeze this, refreeze it. And the string's going to be frozen in there? Yep. Oh, I
Yeah,
got a nice cube
unbelievable.
out. That's definitely restaurant entertainment when they give you your
That's-
water and you don't have anything else. They got the salt, they got everything, all you need is a string. Now, how do I
That's
get
right.
this off? Am I going to go back for the other cubes?
No.
Well, that's pretty amazing. So,
Yeah.
well, let me see if I can. We have a few minutes. We've got about 8 more minutes.
Okay,
So, I want to try this now.
sure.
So,
Go
I'm at
for
the
it.
restaurant. I've got 5 minutes. I'm at the restaurant, and I've got my water. And does it matter how much salt I pour on this?
Well, you're going to drink the water later, so as much as you want, I guess.
Okay.
Actually, I'd put the string in first.
Put the string in first, all right? Then pour this salt. I'm going to see if I can get 2 ice cubes. That's what I thought I was doing last time. Now, and it doesn't matter how much, a little or a lot?
It doesn't take much. You need to wait about 15 seconds to give it time to.
So does it work better in some
thaw and
restaurants like
refreeze.
this Applebee's or?
You know, I'm
Bigger
not going to give any commercial endorsements
Oh,
here
that's right.
on TCTV.
We're not supposed to anyway, but I mean, bigger ice cubes or smaller ice cubes, does any of this matter?
You know, I don't play with my food in restaurants, so I really don't know.
Well, you know, I will be, I've got
Ooh,
it, I've
wow.
got it, I got all 4 of them. All 4 of them.
That's
That
like a
is
trophy.
so fun. See, you could have competitions to see in the restaurant how many pieces of ice you could pick up.
Absolutely.
Yeah, and the parents would hate us for that. But I did get 4. That's fascinating. And now these are all, I'm going to put them back in there. Well, how wonderful. Thank you for coming on our show.
Hey, you bet.
Are there any other, since we have a little bit of time, is there anything else you want to cover?
I can show one little more.
Are there some
experiment
books
here.
you'd like to recommend?
You know, there are a lot of good books.
Have you written a book?
I have not written a book,
Jeff.
but I do have a compilation of science magic stunts that I've done at home that I didn't do here. Although one, Chili Rescue is on here, but this is on my website, edgeamazement.com. If you go to the Science Magic page, you can download this. And also,
I hope they put your website up.
a levitating magician. And the way this works is you can also download this from the Science Magic page, cut around the dotted lines. It'll look like this, but be very careful when you're cutting around the dotted lines. Don't accidentally cut the picture of me, because if you cut him, it hurts me in real life. So just be careful, kids. So Diane, hold your finger out like this. Cast a deep hypnotic spell over the magician, and he will now remain suspended in midair.
Oh, wow. Look at that.
So there is one other
That
thing you
reminds me
need
of
to
the
do.
quarter trick.
Yeah, show them the back of that.
The back has 2 pennies on it.
Yep. And that changes the center of mass. It's exactly like the forks and the...
Wow.
The
So could I
balancing
put him on
coin
the end
trick.
of the glass?
Yeah, sure.
So I could put him anywhere?
Actually, put them right...
I wouldn't mind trying one of the tricks. What would be the easiest trick for me to try with our leftover time?
I recommend exasperated. You take an egg and you cause an egg to float in the middle of water. So it's neither floating on top nor sinking all the way to the bottom, but it's floating in the middle of a column of water.
But we can't do that
No.
because we don't have an egg. But may I do the fork trick or a
Sure.
trick that you did?
Attempt
Which,
one?
yeah, I want to see if I can do that. So
And you've got the forks over there.
Oh, I got the forks. Okay. Where's the purse?
Oh.
Can we do the purse thing again?
Yeah.
They got to see this.
you go.
Get a close-up of this purse. Oh, what?
Okay, you're going to do it. This is not an
Wait,
easy one.
I want to show them how to. Okay, would you do that one more
Sure,
time?
sure.
Could I have the purse back?
No, that's my purse.
No, please, Jeff. Oh,
This is anti-gravity, so that's gravity, and that's reverse gravity, because it's bendy.
it is not, but it's not bendy. This is a real 50-cent piece. Could I have that purse back?
No, that's
please?
my purse. That's where I keep my allowance.
Couldn't I borrow it?
So are you going to do this experiment
I
or not?
am, but I want to see. I want them to see how you use that purse. Okay, so you had this. You made this 50-cent piece stay here by putting. Oh goodness, it was like that. Is that right?
Yep. And actually, I usually use the top tines of the fork, although, because I think it's more stable.
Okay, top
In fact, I know it
tines,
is. Yeah.
like
Yep.
that.
Exactly. Then put the edge of the coin on the edge of the glass.
Okay, oh, there's a close-up. I want them to be able to see that 50-cent piece. It's not working. You just have the magician's touch.
Yeah, at this point, you need to angle the forks in and out until you can kind of feel that it's starting to bounce. But it does takes a knack. Oh,
Well, can we do it? Or is it for me to? Okay. Because I want our kids to know how to do this at home. We're down to 1 minute. I'd love to be able to do this before we. By the way, I want to say hi to all the students at South Bay. I know they love science out there. In fact, they get the best science scores in the district. Probably because Mrs. Metlin runs the science fair every year. Okay. I can feel it wanting to do it. Could you do it?
Sure, sure.
Thank you. Well, we're wrapping up. Again, he has just a regular 50-cent piece. Oh, brother. How long do you practice these tricks?
Well, I was born at a young age.
So, did it take you a while to learn to do these, or does
There's a knack to that, but some of them are self-working. Just give it a shot.
So you are just a very patient person. Don't forget Jeff's website. It's on the ending credits. Thanks to our wonderful crew, Bob Giles, Jerry, Jim, and Tom Dubuque. So join us again sometime. Bye, the students at South Bay, and bye, Mr. Feeney.